Okay, so we're in 2.7 and we're gonna solve these these three problems. Again, all you're doing is you're using that equation over and over again. So now we're going to get a little more far-fetched in a scenario. Let's say the zombies produce radioactive goo that decays continuously with a half-life of 3 years. Okay, that's one more danger of having zombies around. The half-life tells us after 3 years, only half of that amount of goo we started with is remaining. Okay, so this is called decay. And remember, we talked about which equation we would use, right? Just make sure that you make your rate negative because it's decay and you're fine. So technically, the equation that we will be using is A is equal to PE to the negative RT because it's decay, right? You're starting with 10 pounds of goo, and then 5 years later, like how much goo do you have left, right? That's what they're asking. So this rate is it's decreasing. Remember, I talked about that brownie pen, like it's decreasing because every time I go in there, I'm eating half of the amount of brownies that are in there. Okay. So it says if we start with 10 pounds of zombie goo, how much will be remaining after 5 years? So you just want me to figure out what numbers to plug in here? Exactly. So let's just see. Where does the 10 pounds go? Where does the 5 years go? What numbers should I be using here? Okay. Yeah, 10 equals P. Very good. So I'm going to put 10 pounds of goo right here. So that's my 10. And then also ask yourself, what am I looking for? What am I actually looking for too? Does that make sense? Because that's going to help you figure out like what number should I not plug into because I know what I'm doing. Does that make sense? I know what number I shouldn't be looking for. So very good. 10 equals P. E is E, right? You guys have told me that before. Ms. Johnson, E is just E. What about R and T? What about R and T? What about R and T? T is 5. Very good. So over here, I've got T being 5. Good. And what's my R? Okay, so then we're going to Okay, so what we need to do is we need to say this. The only number that we haven't used, I know someone's like half, Ms. Johnson. Okay, the only number we haven't used yet is this 3 years. And that's actually what you need to do first in order to find your R. Okay, I'm just going to tell you right now, this is not going to be part of your test. Okay, this is not part of your test. So if this part is confusing, if you got here with me, then you're fine. So what I'm going to do is I'm going to use this 3 years to find out my half-life. Okay. And so the way I do that is I use this again, except for you'll see what I do. Okay. So the very first thing that I'm going to do is I'm going to plug into this equation. Okay. And the way I plug into this equation to find my R, this is to find R. And what it's called is it's like you're trying to find your half-life. You're trying to find that half-life rate percentage to find R. Okay, so what I'm going to do is I'm going to use this 3 years. Now 3 years is actually going to go in my T just like before. So A equals PE to the negative RT. And in this case, my T is 3 years. Ms. Johnson, why is it 3 years? Well, it's 3 years because that's what they told me my half-life is, meaning I have half the amount of stuff left. Okay, so just for the sake of argument, you can use whatever number you want, but because they gave me 10, I'm going to use that here. So they gave me 10, so I'm going to use 10. And I'm trying to look for R. And they said after 3 years, you have half the amount of goo. Well, if I started with 10 and I'm leaving it alone for 3 years, how much stuff would be left after 3 years? How much stuff would be left after 3 years? Yeah, half of it. Half of it would be left, right? Because that's what the whole point of half of it. So remember my little brownie example? If I had 10 brownies and at first pass you guys go through, I'm going to pretend that this is everybody, not just Miss Johnson. Half of my brownies go away. How many brownies are left? Right? It's 5 of them. Does that make sense? So the first thing that I do is I figure out the rate. So I'm going to solve this for you really quick. You should know that we divide by 10 because of SADMAP, right? So now we get 1/2 is equal to e to the 3r. I mean, earlier today, we learned that if I want the exponent out of my e, what would I do to both sides? What would I do to both sides? Yeah, I would take the log base e. Very good. And you can actually put both. If you said, Miss Johnson, take log base e of both sides, that's fine. If you said, Miss Johnson, I want to be fancy, I'm going to put natural log on both sides, that's fine. Either way, if you told me log base e or natural log, those are the same thing, right? So some of you call me Mrs. Johnson, my children call me mom, different name, same person. Okay, so you should see this as canceling, or they undo each other. So I'm left with 3r equals to natural log of half. And I know it looks yucky, like you're like, ew, Miss Johnson, what is this natural log of half? It's a number that Desmos is going to tell me in a little bit. Okay, so now what do I do? What do I do now? What do I do now? Yes, divide by 3. Very good. Okay, so I divide by 3. I divide by 3. R is equal to natural log of 1/2 divided by 3. Now be careful when you plug into, make sure that it looks like what you want it to look like. So let me clear these out. Boom, 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 boom. Okay, so let me let this catch up because it's not caught up. Okay, so this is natural log of 1/2. Is this the way I want it to look? Do I want my natural log of 1/2 to look like this? Yay or nay? No, this is actually the natural log of 1, then divide that by 2. So Ms. Johnson, how would you fix it? Well, I just put parentheses right here. And then I'd hit divide by inside my little parentheses. Then it knows. So is this the way I want my natural log of half to look like? Is this the way I want my natural log of 1/2 to look like? The answer is, yeah, right? So for those of you who don't see the difference, let me put both of them here so that you see the difference. Number one, the value is different. So here's the wrong answer and here's the right answer. And then 1/2 needs to be inside my log. Okay. And then I want to divide the whole thing by 3. So let me see if I can do divided by, oops, that's minus, divided by 3. Is this how I want my expression to look? Is this how I want my, yeah. And so notice here, some of you are like, Miss Johnson, why is this a negative? Well, remember we talked about it decaying? Like we had 10 brownies and at first pass, you guys only left half of them. And then I'm like, man, those brownies went fast, quick. Maybe it's 3 minutes, not 3 years, because then that's gross, right? Okay, so then our R is equal to, our R is about 0.231. And so some of you are like, Ms. Johnson, do you want me to keep the negative there? Yeah, just make sure that you understand that this rate means, and I will write that out, this rate, because it's negative, means that it's a decay. meaning I had 10 brownies. And then at first pass, you guys had half of them. So now there's 5 brownies. At second pass, you guys are eating half of those. So now I'm left with 2.5. Do you guys all see how it's decaying? My brownies are diminishing. I don't think I would use the word decaying. That sounds gross. So there's my rate. Okay, so now that I have this rate, now I can take my rate and plug it in right here. So now that guy goes in there. So there's my rate. So that all that for this times -0. Oops, let me erase this so I have more space. Negative 0.231. Is that right? Yeah. And then times my 5 years. Yeah. So times by 5 years. And then, so that's me just plugging into a calculator. So I'm going to plug this into a calculator. And then again, I'm going to make sure that I plug it into my calculator really well because I don't want to be wrong on a test. So 10e to the, and I already know I need a parenthesis, so I'm going to put that there, -0.231 times 5. So my answer is 3.15 what? If I started with 10 pounds, how much is left? About 3.15 pounds of goop. I'm not even going to put zombie goop. I refuse. I'll just leave it right there. So is that okay? So Ms. Johnson, you had to find the rate first. Yeah. And finding the rate isn't too bad. You just have to understand what they're talking about. How did you know to use 10? I didn't. They just gave me 10 and they told me after 3 years, it's going to be half of that. So that's why the biggest ratio here that I needed was this number right here, that these two simplified to be a half, hence the word half-life. Okay. How long will it take for the amount of zombie goo to decay to less than half a pound? Less than half a pound. Okay, so sounds good. So because I love my calculator so much, I'm going to plug this in. And instead of using the 5 there, I'm going to use the number x, right? Because that's my function. And they want to know when it's less than half a pound. So again, I'm going to be plugging in y equals 0.5 because I want to know when it's less than that, right? So I want to know when this function goes below half of a pound. Okay, so I'm going to get this really big. So I'm like, where'd my function go? And it's all the way over there. So I'm going to zoom out a little. And then there I see it. And so I'm going to click on this point and it tells me at 12.69, 96.9 years, basically 13 years. At 13 years, it's at half a pound. So I want to go a little bit past that. So what number will Miss Johnson use? And this is what we talked about. How many years should I put? How many years should I put there? How long will it take? Yeah, I would put 13. Okay. Now some of you are thinking, oh, Miss Johnson, you put 13 years because you rounded, and that's not true. If I go to the right, notice here, this blue curve is going below less than 0.5. And that's what they asked us, right? They asked us, how long will it take for the zombie goo to go below less than half a pound? Okay. So Ms. Johnson, why didn't you just leave it at 12.969? Because that's exactly a half a pound. They wanted less than that. Okay. So if you put 12 point, what was the answer? I forgot it already. If you put 12.97, that's a fine answer, but I'm looking for more like whole years, right? Like what if, like I think when you guys were little, you guys used to be like, how old are you? And you're like, I'm 8.5, right? I don't say my half ages anymore, right? You probably don't either. So, so we just leave it as a whole number of 13 years, okay? All right, let's move on to the next thing. The last question in this little part, it says, when will there be no goo left? No, none of it, none of it. So for all the goo to be gone, would it be 13.5 years? I don't know, let's look. So the next question is, when will it all be gone? So I'm looking here and I can't really tell. And remember, this is technically an asymptote, right? So technically, if you think about it, now think about my brownie example, right? So at first pass, you guys eat half the brownies, there's 5 brownies left. At second pass, now there's 2.5 brownies left. At third pass, there's 1.25 brownies left. Do you see how each time you take half of it? Okay, now there's this tiny little crumb that's like after so many passes. Do you technically see how there will always be some of the brownie left? And eventually one of you will just take the crumb and pop it in your mouth and we're all good. But for here, the zombie goo technically will never be at 0, right? Technically, right? Because this is an asymptote. We talked about this before, right? Because this is an asymptote, it won't ever technically be there. But for like practical perspectives, like, okay, so when will it be like, less than, I don't know, 1/10 of a pound or something, Miss Johnson? So if you want to go from that perspective, then we would solve an equation, right? Or here we would go like, I want it to be less than 1/10 of a pound, and then I'd see where they came together. And if you guys want to be more accurate, you're like, no, Miss Johnson, that's too much goo. Then you would be like, okay, less than, 1/100th of a pound. And then I would be like, okay, that's like 29 meters. And you're like, no, Miss Johnson, let's go crazier and let's make it even less. And then I would have to find that point because I don't see it anymore. Does that make sense? So does that help you? That the answer technically would be there would always be some left, but for practical purposes, in terms of how much we can actually measure, right? That 30-year point was pretty good. I think that was a pretty good answer when we went to 1/100th of a pound, right? Where was that? Where are you? I don't know, it was here somewhere. Where is it? Yeah, it's right here somewhere. There it is, right there. So about 30 years, that would be a pretty good answer. And you're just saying, hey, Miss Johnson, I'm not going to measure anything less than 1/100th of a pound. I think we're good. Right. Think about how small 1/100th of a pound is. Good. Very good work.